Experiment 7C. Explosion. Other than collision, two trolleys may interact in an explosion. A loaded spring is released by hammering its plunger, and the two trolleys will move apart. Two motion sensors are necessary to detect the individual velocities of A and B in different directions.
Set up one motion sensor on each end of a runway. Connect both motion sensors to the interface. Place two trolleys, A and B, in contact end-on in the middle of the level runway. Release the plunger and observe what happens. Run the data logging program and start data recording. Release the plunger so that the two trolleys explode, moving off in opposite directions. Note the VT graph displayed. Read the velocities of the trolleys before and after explosion. Repeat the experiment by doubling the mass of trolley A. Note the VT graph displayed. Read the velocities of the trolleys before and after explosion. Repeat the experiment by tripling the mass of trolley A. Note the VT graph displayed. Read the velocities of the trolleys before and after explosion. Put the results in a table and calculate the momentum of the trolleys before and after explosion. Find out if momentum is conserved in explosions.
As the trolleys move towards their own motion sensor, the final velocities will both appear to be negative in their velocity time graph. However, if we take the velocity to the right to be positive, the velocity of B should be taken as positive when recorded in the table. In this experiment, we have to level the runway but not to set it for friction compensation, as the trolleys move to two sides, and so there's no way to reduce the effect of friction for both of them at the same time. Within the limits of experimental error, the total momentum of the system is conserved in an explosion. On the other hand, the kinetic energy increases in an explosion as the potential energy of the loaded spring plunger is released. Table 7.1e summarizes the results, and it is now reasonable to say that the total momentum of a system is always conserved, provided there is no external net force acting on the system. So when there is an external force, such as friction, exerts on any object of the system, the total momentum is not conserved anymore. On the other hand, internal forces between objects of the system do not affect its total momentum. Lastly, only the total momentum is conserved. The momentum of a single object of a system is properly not conserved. In example 2, Two ice hockey players collide and stick together. They travel in opposite directions before colliding, and so the initial velocity to the left is taken to be negative. Their common final velocity is found to be positive, towards right in this case. As we know the initial and final velocities, we may find the force acting on each of them as well. Suppose the collision takes time t, so fxy equals mx multiplied with vx minus ux divided by t, and fyx equals my multiplied with vy minus uy divided by t. In example 3, Mark and Joanna pushes each other on ice. It is similar to an explosion between them. Applying the conservation of momentum, we can find the final velocity of Mark when he leaves Joanna. Now try check point 1 below.